And of course, this section includes layer 4 to layer 7 service insertion. It includes a little bit about fabric security, some things that are inbuilt into the product. It also includes how you would create users, assign them different roles, and the users could be local users, radius users, JACAX users, LDAP users. That means we can have external providers, authentication, and our AAA providers could be external devices. We'll also be looking at a little bit of monitoring, some fault management, logging, and finally we wrap it up with net flow configuration. So we'll start off with the topic, which is layer 4 to layer 7 service insertion. All the traffic that has to be examined deeper, or devices which do deeper examination in order to make forwarding decisions. Okay. Deeper packet inspection, that means at least examine layer 4, port numbers probably, or even deeper, layer 5, layer 6, layer 7. Those are industry-wide known as layer 4 to layer 7 service devices. Okay. It's not a Cisco term. They are known as layer 4 to layer 7 service devices. The service insertion is purely about how you would add your firewalls or your load balancers or your IPS or your IDS, or as we know, they also call them the load balancers, or sometimes known as application delivery controllers when they're very specific to applications. Maybe a specific type of firewall, web application firewall. Any of these would fall under this category. Okay. Now, in the ACI environment, currently, as we speak, there are 3 approaches to service insertion. Your book, which is about 6 slides, talks about an approach called managed mode. Okay. There are 3 approaches. It's called managed, unmanaged, hybrid. Hybrid is the preferred option now. Managed was the only option that Cisco supported, or that was support only for managed mode at one time. Then they said, no, we can have unmanaged mode, which means the ACI environment does not configure your service device at all. The only thing the ACI or the network engineer would do is make sure we have the right VRFs and the right VLANs. That's called traditional method of service insertion. Just configure the ports, the access codes of the leaf switch with the right settings. Okay, that's unmanaged mode. And hybrid mode is a combination of both. There's some amount of managed configuration, and the device itself is unmanaged. So we're going to take a look at a hybrid approach also. That's not something that is in your book. I'll just discuss it as part of service graph or service insertion. Okay, that's Okay, you can't read it probably. I'll go ahead and share that link. So you'll find it handy. But this is about something called a service graph. A graph is nothing but like a picture, kind of like this, right? This is a graph. Something where you can drag your service devices, put it into a linear manner and say, well, I want to use it between these two EPGs, for example. That's a graph. Okay. So we're going to take a look at the approach. When do you want to use a service graph? And the three models for the service graph. Well, you might see this one called network policy model, which is what I call the unmanaged mode. Okay. A network policy model, we'll see a corresponding diagram so you get a better idea. Unmanaged mode. Well, in this mode, ACI configures only the network portion. That means the network settings of this graph. What do they mean by that? Well, it takes care of the network settings as it connects to ensures that your port's configuration is done fine. Okay. ACI does not push any configuration. It doesn't control the layer 4 to layer 7 device at all. That means it doesn't dictate any firewall rules or any load balancing rules ever, doesn't make any changes, no configuration changes being done to the layer 4 to layer 7 device. That's called the unmanaged mode, or it's termed the network policy mode. The first mode that was supported is managed mode. It's also known as service policy mode. Well, in this mode, ACI configures the fabric ports and the layer 4 to layer 7 device VLAN and the layer 4 to layer 7 device configuration. That's the first mode that Cisco supported. That's the one you're going to see. The third mode, the firewall or load balancer or service device administrator defines the layer 4 to layer 7 policy. ACI configures the fabric, the device VLANs, and the APIC administrator can kind of associate, they can actually retrieve the policy. Like they can pull the policy out of this device, they can pull that and associate it with your network policy that you've configured. Third mode is the hybrid mode, and it's essentially probably the most widely used since about 1.5 years. So there's a flowchart showing you when you need that's actually a manual insertion showing you that you have to configure the right VRFs and the VLANs and so on. Let me see if I have the graph showing us okay. Network policy mode. That means this is unmanaged. The network administrator manages the fabric, but not the firewall or load balancer. So the network administrator makes changes to the entire fabric, but does not have any access. Cannot retrieve, cannot make changes, nothing to the firewall or the load balancer. Oops. Okay, so that's the unmanaged mode. The unmanaged mode is pronounced or shown a little bit more explicitly. It shows you the administrator of the firewall or the load balancer manages the device through its own management tool. Service policy mode, also known as the managed mode. You can see, guess what this person has to do? This person has to give all of their requirements, the settings for the firewall or the load balancer, all of those settings to the APIC administrator, who then renders it via the APIC, and the APIC makes the changes to these devices, the firewall or the load balancer. It also shows you the network, the load balancer, the firewall administrator is able to read those settings. The third is the service manager mode. It's called the hybrid mode, as you can see. If you read it, it says the layer 4 to 7 administrator configures the device through its own management tool. The APIC administrator configures a graph, and they can actually read, they can retrieve the information that this person has actually configured. They can actually pull it and then associate it with their settings. That's what they call the service manager mode. Now, there is another model that has currently become probably for the last 6 to 8 months I've been seeing, where there is a higher level orchestrator, which means you don't configure the layer 4 or layer 7 device, layer 4 to layer 7 device through the APIC or through the product's own management tool, typically done through a higher level orchestrator. Okay, maybe something like OpenStack or something like VMware vRealize, or maybe the Cisco Cloud Center. Higher level orchestrators would influence the network requirements, convey that to the APIC, and also convey the layer 4 to layer 7 requirements to the actual tool of that layer 4 to layer 7 device. That's become prominent or gaining prominence in large, very large organizations. I haven't seen it in mid-sized as yet, but that's a fourth approach that is being adopted, a higher level orchestration product. And it's gaining more importance in cloud provider environments. Okay, well, the tenant or the customer would provision their requirements through some self-service portal, and that self-service portal is a front end through which they would specify they have these applications need a load balancer, need a firewall, and then it will go ahead and influence those changes. So unfortunately, the only option we can try, because our lab has got only an ASA virtual, the only option we can try is the managed mode. And it is the only firewall they have. So we're going to take a look at managed mode. It just tells you that it automates the service device, the insertion of the service device, whether it's a physical or a virtual entity, configures the device according to the functions profile. So you're going to go ahead and define a profile. You're going to specify what it should do. Okay, whether it should be behaving. For example, you can route to a firewall, you can bridge to a firewall. And most of the time, you either use the firewall as a default gateway, which is what many of us do, or the firewall may be a bump in the wire. If you force your traffic to go through the firewall by routing design, which means you essentially design your routing protocol exchange with the firewall so it travels through the firewall. Well, you hardly ever use the firewall as a switched device or a transparent mode device. Okay. But it does depend on how you've traditionally been using your firewall. That's the approach you're going to take. But anytime you add a device, it has got these different roles or different behaviors. You can route to it. You can use it as a default gateway. You can switch to it. So these are called function profiles. The developer of the product gives you these profiles to choose from. And accordingly, you've got to configure those through the APIC. In this example, they've highlighted that it becomes easy to go ahead and direct your traffic between the web and the app by simply inserting what is called a service graph. A service graph is a collection of service devices in a specific order. You insert that into your contract. In other words, you specify what type of traffic is permitted in the contract, and accordingly, you can get that traffic redirected into the service graph. Now remember, I mentioned contract has subjects. A contract typically has subjects. So you can have one or more subjects. Within the subject, you got your filter, optionally QoS, and then you have your service graph also. So I could have a contract which has a graph applied to a subject, which means certain traffic types, but no graph applied to subject 2, maybe a graph applied to subject 3, which is a different set of filters. So it kind of gives me control. The policy gives me control about redirecting certain types of traffic through my service entities. Okay. So what are the deployment methods? Now, here it does talk about, well, if you're using managed mode, you either get what's called device packages provided by the vendor. This is provided by the vendor. And then you upload these into the APIC environment. There's a section where we go ahead and upload the device package files, which is a minimum of 2 files. Or The other way to do managed service device insertion is, of course, the vendor goes ahead and implements OpFlex engines or OpFlex agents into their product. So OpFlex is a protocol which is, of course, used by the APIC to communicate or send control messages towards your switches. That's how it sends the policy information to the switches. Tells it, hey, you need to create this VRF, you need to create this VLAN, you need to create these VXLANs. That's used. OpFlex was developed by Cisco, Microsoft, Red Hat, Citrix, and F5. Cisco, Microsoft, Red Hat, Citrix, F5. Yeah, they got together. Now it is an IETF standard, and it is, of course, open source. So if a vendor implements the OpFlex engine, that would be another approach. Okay. Third approach is the unmanaged mode, totally unmanaged. You just configure the VRF and the VLAN on the access ports. This is when the APIC does not provision the service device at all. You could use a top-level orchestrator. Notice they've not mentioned the hybrid mode here. This is using a orchestrator like UCS Director or Prime Service Catalog, or as I mentioned, it could be OpenStack or probably even VMware vRealize. We start with what is a device package. I would say a compressed file, like a zip file, containing a minimum of 2 files. What are the 2 minimum files it needs? An XML file. So you can see one here. It's an XML format. What it does, it ensures all properties of your service device is organized as objects, MOs, managed objects, in the management information tree. That's the purpose, because you already know one thing. The APIC actually has a model of the entire fabric, a virtual model. Every time you make a change in the APIC, it's actually saving against this model. It's not directly sending instructions to the switch right then and there. It's not sending the command line either. In fact, it never sends command line from the APIC. It doesn't send a command line to your switches. It saves it in the APIC's model, management information tree, and then it sends it out towards the switches in OpFlex messages. And the switch itself is responsible for converting it into command line. So this is very much needed. The APIC has to be able to see the configuration, read operational information. So everything has to be organized somewhere within the tree. That's what this XML file does. Tree with, or at least it will fall somewhere. It's a branch called mdev. It will fall somewhere within the MIT script file. Any APIC event? Add a rule into a firewall, that's an APIC event. It actually has to go ahead and render it into the required command line of the device. Okay, that's the script. Any APIC events to the actual device interactions. Including, if I were to say, change the security level of my outside interface at the firewall to a certain value, that would be an APIC event. Go ahead and change the security level. It has to convert it into the required command line. That would be done by the device script. It's actually a Python file. So there is a little bit. It's an XML file, defines the specification. Every configurable object, operational object. What am I meaning by that? Everything that you would possibly configure on the firewall or the load balancer. Every show command that you would retrieve, it's an operational value. All of those are objects that need to show up in the management information tree. That's what this XML file is doing, a hierarchy of the managed objects. Okay. It will include the device type, the management IP, the management interface, the credentials, all of this in the XML file, or fields to populate. Okay. The term service graph rendering. When you actually associate a graph with a contract, that's when it goes ahead and pushes it. When you actually add these firewalls and load balancers into the graph, when you design this page out, the firewall doesn't know its inside and outside security levels. It doesn't know its inside and outside IP addresses. It doesn't know its rules. Load balancer doesn't know its load balancing methods or algorithm. It knows nothing. Rendering means when you apply the graph to a subject, that's called rendering. That's when it actually, your APIC is going to go ahead and send the firewall rules, the IP addresses, the interface security levels, and if the firewall supports context, all of those parameters are then sent. So rendering is a very important aspect. You specify, it basically identifies between which EPGs and thus configure the ACI environment according to that. We do know that the sole purpose of the XML file is to make sure that we have a managed object model. Now notice it says the device script file, its responsibility is to render the messages, convert. So this is all in the APIC, remember, when you're making a change, changing a firewall rule. It's basically saving it as part of this model and then utilizes the script file to render it into the third party's command line, or if the third party is using a REST API, converts into a REST request, or if they are 1PK here, converts it to 1PK. It depends on what the third party uses for rendering updates to their device. So this entire package is provided by the third party vendor. So it's a very integral part of an application. Okay, what does a graph do? Identifies which services are needed by the application, which firewalls, which load balancers. And as I mentioned, once the graph is configured, when you apply it to the subject in the contract, the APIC automatically configures the service device according to the function parameters that you have specified. I would say it is represented more like another tier added, okay, to your two-tier or three-tier environment. It's more represented as a additional tier. As you may notice, they've said it is a collection of service devices. It doesn't have to be the entire permit statements of the contract. It's actually being selected because it's only applicable to a subject. Service graph, you can actually go ahead and specify the order in which these devices are to be used. You can use this for devices which work in active standby mode, cluster mode. Keep in mind this whole device package or OpFlex is implemented by the vendor. So it knows, the vendor knows they have clustering. So they make sure that they provide us with the device package accordingly. And thus the APIC can provision the service device correctly. Use cases would be to go ahead and add any of these. Could be application firewalls, IPS, packet mirrors, like taps, load balancing. Shows you ADCs. Now, when you go ahead and load the device package, for example, you load a firewall, it'll ask you, or you load a load balancer, it will ask you 1-arm mode, 2-arm mode. When you load a firewall, it's going to ask you, the choices are you going to route to it? Are you going to switch to it? Are you going to use it as a default gateway? Well, based on the profile that you select, it will need parameters. Parameters could be simple things like the security level of an interface. It could be firewall rules. It could be load balancing algorithm, virtual IP for the load balancer. Example, this particular service device, the gray one, they've actually shown you, it supports 2 functions. So when you configure the profile for the SSL offload, you could specify the SSL parameters. When you configure the profile for the load balancer, you could specify the load balancing algorithm and maybe other settings pertinent to that window. So how do you specify the parameters? You can specify it within an EPG. You can specify it within an application profile. So if you're dedicating a firewall for a certain profile only, you would specify it with an application profile. Firewall is used by all applications in the tenant. You would specify it in a tenant context rather than a specific application. That's the term. It shows you service graph being rendered, a collection of service devices within the graph. And then when you apply it on your subject, which is within a contract, the firewall obtains its parameters, and thus your firewall rules take effect. The function profile, this is provided by the vendor. You'd be asked during configuration, depending on the type of service device, you'll be asked, hey, which function profile, are you applying it to a cluster? So The function profile provided by the vendor will contain all the configurable parameters, and they're actually organized into folders. So that's something that you would have to choose. There will be multiple function profiles. For example, I mentioned a firewall. You might have, are you going to be using it in routed mode? Are you going to be using it in transparent switched mode? So we'll provide, and each of these have their own parameters that need to be configured. So based on the function profile you select, it would let you configure the parameters. Similarly, a logical device. What you're configuring within the APIC is the logical representation, your GUI or your command line or your Python script, or even instructions coming from, say, UCS director or something. The APIC essentially has a logical device. And the actual device could be a VM or a physical firewall. So this logical device will present itself either as a cluster with all its interfaces. You're going to be configuring those settings. And when you do the graph rendering is when it actually goes to, these are called the concrete devices. Okay. Their physical interfaces are mapped to whatever you have the interfaces in here are called the logical interfaces. So just like you would do a physical configuration of a firewall, you've got to configure some settings. Instead, you're going to go through the APIC and configure the firewall, but it's actually done through a logical device. It's like a model. And then this model sends it to the, so it could be a cluster of devices. They have their own logical interfaces. And when you render it, those logical interfaces are mapped to the physical, and then the VLANs and VXLANs are programmed on the actual device itself. So before you render them, you've got to make sure that the actual device has an IP address, you know its management IP, so you can provide all this as part of the configuration in the APIC. You've got to specify its management IP on the actual device, your firewall or your load balancer. It's going to have a management IP, some username and password, some administrative username and password. And make sure the management interface is connected to your fabric. So you want to make sure you do that. Once you do that, you would go to register the device. Register has to be done before you do the service graph rendering, which means the actual concrete device, it should have an IP address on its management interface. You should have already configured a username and password on it and made sure you connected the management interface to your ACI environment. Only then you go with the registration aspect. So here it actually shows you an overview about what you would ideally do as far as the service graph in managed mode. You're going to go ahead and define the device. But before you define the device, oh, I forgot, import the package. Only then you can define it, because unless you have a Windows device package file, you don't have the model within the APIC, so you really can't define it. So you're going to go ahead and import the package. Based on this, you'll be defining the device. So you'd actually specify how to register to it, you'd specify the function profile and the parameters. Now, in this one, you're going to specify, you want to build a graph, and then in the graph, you specify the order. I want the firewall first, and then maybe a load balancer, or I want only a firewall, no load balancer. That's a graph template that you create. Then you apply it to your EPGs by applying it to the contracts. And then, of course, you should be able to verify that these settings have been propagated onto your layer 4 to layer 7 device. You can always verify it on your layer 4 to layer 7 device. The settings should propagate there. We will be doing that lab later. We'll move over to the fabric security. So there's always constant threats directed at data centers. So of course, that would mean you want to ensure that your data center environment is secure. So we increasingly are trying to use newer applications, physical or virtual, or maybe even on the cloud environment. BYOD initiatives, we are looking at those, how to make sure that those are also secure. Then increasingly in the data center, we have a lot of east-west traffic communication rather than north-south. North-south used to be trend in the past, long ago. Now, a lot of applications are multi-tier, so we have a lot of east-west communication. Now, Cisco did ensure that somehow this architecture is secure. If you think about it, it has what's called a zero trust model. It is, as you can call it, stateless firewall. Devices cannot communicate between EPGs by default. So we call this the whitelist model of networking. ACI is called the whitelist model of networking. All previous data center solutions were termed as the blacklist model of networking. Whether you had Nexus or Catalyst or any other vendor, they were blacklists. Everything in the data center communicates by default unless you blacklist them. This architecture is inherently a whitelist model. Devices between EPGs do not communicate. And you can even go to the extent that devices within EPGs do not communicate unless you explicitly permit. So if you think about it, ACI actually has a zero trust model and hackers hate the product. It does depend on several layers of security. Okay. So you need to remember, pretty much everything is centrally configured via the APIC. So if your APIC is compromised, we have a serious security breach. Okay. So everything is centrally configured. If the APIC is compromised, we are in deep trouble. You might as well generate a resume and look for another job. Cisco has some built-in measures to ensure your APIC is hardened. They already used one of the most hardened operating systems called the CentOS. This is a Linux distro which is already very well hardened. We only opened limited number of ports, 22, 443, that means SSH, and HTTPS. In fact, port 80 is automatically set to redirect to HTTPS. So that's something they also did what is called API throttling. So the REST API, the number of transactions it handles per second is actually limited. Okay, one, to ensure that it doesn't slow down the active transactions, to keep those open. And also, you don't want possible security breaches by allowing the API to handle too many. You could invoke, if it can handle too many transactions every second, you could invoke dictionary attacks. So inherently, they have throttled the number of transactions per second. If you do want to, in fact, I did enable port 80 in our lab environment because we had not done any form of certificate servers or certificate exchange. None of that was done. I did enable it. You can do that under the Fabric menu, under Fabric policies. You can go ahead and change the pods policy. There's a section for management access. You can go ahead and enable HTTP, or just leave it as the default, redirect it to HTTPS. We've already discussed the northbound API. The northbound API is REST. So if you go ahead and interact with it using GUI, command line, a REST client, or a Python script, or a third-party orchestrator, this API is known to only accept encoding formats or text formats. As defined by the IETF, it only accepts you do have a command line on the APIC, which they call the NXOS style command line, which has been available since 1.3, I guess. Before that, it was Bash, object-oriented command line. The encoding format, it doesn't matter which of these applications or utilities you use to interact with REST, it will always stay JSON or XML. And if you look at the API inspector, you would see that it displays it in JSON, the API inspector. Since your APIC can become a point of attack, it's very important to secure it. So there are several ways to ensure that the APIC is secure. Now, we already know that for the web interface, you have the option to use HTTP or HTTPS. How secure is HTTPS? How secure is HTTPS? Okay, true. The answer is correct. Depends on the certificates used, the encryption type. TLS type. Okay. So you do have web interface, or if you're using the REST API with the REST client, you can go ahead and use HTTP or HTTPS. And the first thing, when it authenticates by default, when you send username and password, it gives us a web token. Anyone seen that web token when we did Postman yesterday? Did send your username and password as the body, and of course the response was a big long hash of characters called the token. It also, if you didn't observe it earlier, it specifies the permissions, the authorization level, what domain, that means which tenant, and the role of this user. Well, username and password may not be a very secure approach if your session is not HTTPS. So another form of authentication, X.509 certificate. For each user, now this is actually a little bit complex to set up. For each user, you can go ahead and add their public certificate. And that means when they connect from the REST client, it's going to go ahead and send something with a private key, and of course the public key will validate it. Okay, it's going to send a signature based on the private key, because the private key is stored securely on the client side. So here it's using certificate login. This is more secure than using username and password, but it is a little bit more cumbersome. Now, it's good if you had only 3 or 4 administrators, you can load certificate information for each of those users. They have to be performed manually. Only local users are supported. You cannot use remote users for X.509 certificates. The other thing is this works with any REST client, but it doesn't work with the APIC GUI. So then again, I'm not sure how much you want to use that option. It doesn't support third-party CA servers. It would have to be self-signed certificate. The other option you have is, of course, your SSH login. By default, SSH login uses username and password, but you can go ahead, similar to how we use an X.509 certificate, you can associate an SSH public key with your local user. That's what it says. It just uses username and the public key. This might be more ideal if you want to run scripts that use SSH, so you can run it automated without having to provide the password. Okay, of course, both of these ones that I've highlighted, you'll have to upload. You'll have to go to each user and then insert for each user, add their certificate or the public key for SSH purposes. You'll have to go ahead and load it. Authentication methods. By default, we have been doing, it's a lab environment, we've been doing local authentication. Okay. Now, when you add users, you may have seen, it does ask me, when I did add a user, if I still go ahead and do that, you'd notice it asks me a question. I did add a user admin 2 there, but just let's add this user example. And as I click, you may notice what's the option to add the certificate right here. You see the public certificate and the SSH key right here. Here's a question. It asks me which security domain. If I click this, I'm basically saying that I want this user to be a Fabric-wide administrator. Okay. If I click a specific tenant, I can actually go ahead and click a specific tenant. Though you don't see it here, it's because we haven't created what we call additional security domains. We haven't created them. You can create additional security domains. That's something that you're going to do later in a lab. And then associate with a tenant. So when I click the domain, it is indirectly saying which tenant or tenants. The domain can be associated with multiple tenant or tenants. These are default security domains. You can actually see them. Default ones. I actually cannot delete these default ones. Okay. But I could add more security domains. You see, there's an option to create, but look at all, delete is grayed out. I look at common, delete is grayed out. That actually means common tenant management. Management is grayed out. That means management tenant, by the way. So I can create my own, just give it whatever name you want, and then you can associate the domain with one or more tenant. On each tenant, there is a field to configure the security domain. Yeah, right there. You see, there's an option here to add and choose the domain. So every time you add a user locally, it's going to ask you for the domain and, of course, the role. The role defines the, remember, what's the difference between authentication and authorization? What's the difference? Difference between authentication and authorization. Thank you, Amar. Who you are is authentication. What you can do is authorization. Thank you. Login and roles. Yes, you can probably log in, but what you can do is authorization. So roles, okay? Roles are going to be assigned. What you can do. Now keep this in mind. If you choose all, the person becomes choose the domain as all. When you add the local user or when you add a remote user, you specify it with AV pair, attribute value pair. Well, if you do that, the domain all makes the person a Fabric-wide administrator. If the domain is a specific domain which is tied to one tenant, that person will become more like a tenant administrator if you give them admin role. So the tenant administrator can only do tenant-related tasks. They have full permissions to the tenant, but cannot configure anything under the Fabric menu. Only a Fabric administrator can configure anything under the Fabric menu. Tenant administrator can only do tenant-related tasks. Now, in addition to local authentication, we also have centralized authentication servers. Choices would be your Radius, TACAX, LDAP, or any LDAP, and Active Directory integration. Well, here is something that you've got to keep in mind. If you have something called a stretched fabric, or you have multiple pod environments and your APICs are distributed in different sites. Let's say you have 5 APICs, 2 on the main site and 1 each in some other sites because you have a multiple pod environment. Okay. And of course, if you lose connectivity between these sites, the pods or the sites with 1 APIC, they will not be able to do remote authentication. The system will fall back. You can do local authentication. Local authentication information is stored in every APIC individually. Remote authentication, not the case. It is actually spread across in shards. So it will not function correctly. The fallback is local authentication. Starting with 3.11, Cisco introduced kind of like a keep alive feature. So the APIC can, ahead of time, keep sending these heartbeats or keep logging into these servers to check if the Radius server is alive, the TACAX server is alive, the LDAP server is alive, or your Active Directory server is available or not. You may have some environments which may have selected 2FA, two-factor authentication. User would be two-factor involved. What does the user know and what does the user have? Okay. They know their username and password. They probably have a token or an application or an app on their phone, something which generates a token number, which they would use as their 2FA is usually when your APICs are typically in the data center. They're supposed to be or considered a more secure zone. And of course, some organizations may require 2FA while accessing these nodes. Shows you an example of how they've integrated with Semantics VIP access, the cloud-based authentication service, which provides you the added security of, other than username and password, you need a security code. So security codes are generated by the user using some form of Cisco validated app that you would get from Semantic VIP. That's when you go ahead. They do have a few that they've supported for 2FA, not only Semantic VIP, they've actually increased some more vendors you can work with. Now we look at the APIC to switch, authentication and encryption. The APIC is a server. It has a TPM module in there, the Trusted Platform module, where it stores its digitally signed certificates. TPM is well known as a hardware cryptographic module. The switches, the Nexus switches, have an Act 2 modules. They are also pretty good. They are embedded on the motherboard, so you can store certificates in there. At the time of manufacture, Cisco does store certificates in these hardware modules. So in the Act 2 HSM, which is on the switches, as well as in the TPM, they are digitally signed and stored and, of course, encrypted at the time of manufacture. So when you go ahead and add them in, right there, add them into a Cisco APIC environment. When they're being discovered, the APIC can actually determine if there are any rogue devices. If there are rogue devices, they will not be added to the fabric. And of course, that means they will not have access to any ACI. Well, all communication, as I mentioned early on Monday, infrastructure VLAN. Initial communication, as always, APIC to switch is performed over the IFN channel, which is in-band over the infrastructure VLAN on the switch. By default, that VLAN is closed in every device. It will only be opened after the device has been authenticated by the APIC. And of course, after that, we have the IFN channel communication, which takes place for image management, configuration, like policy updates, endpoint declaration, all kinds of OpFlex, statistics collection, telemetry information, all of that is encrypted using TLS 1.2. What is COOP or QOP? Anyone remember what's the purpose of this protocol? Thank you, Victor. What is the use? Council of Oracles protocol. What is the purpose of this protocol in Cisco ACI? Council of Oracle, thank you, Derek, knows every endpoint. Remember, the switches learn about the endpoint, the leaf switches learn about the endpoint information has to be sent to the spine switches. That's where this protocol comes in. So you can see the blue arrow there showing COOP. That's the leaf switch, learns about the endpoint. And then it sends it to the spine, and the spines will also use to synchronize the table. So they have a consistent copy of the proxy table. So this is a programming terminology, zero message queuing. It's actually an industry-wide internal method used to queue messages between devices, and programmers are well versed with it. So this one is also authenticated. You can change, you can say, well, COOP should only communicate with other devices using MD5 authentication. Strict mode, that's what it's called. Compatible mode, which is the other one, is COOP protocol can communicate with both MD5 authenticated as well as non-authenticated zero message queuing for message exchange. Default is strict. You can only change it through the command line. Image distribution in the fabric is also protected, as you can see. Image download is completely protected. You see how they're going about it? Actually showing you that the image is signed, right? This is the APIC. By the way, all UCS servers have the TPM, not just UCS, and pretty much most vendors have TPM modules in there. So Cisco is storing the APIC certificates in there, shows that it is created a signature, and of course sends it. And here, this has the public key, and it's verifying the hash. Okay, because this was signed by private. Verification is done using public. So both these are hashes, by the way. So it's actually verifying that the image is a valid one. Next is our discussion on role-based access control. First, the role is going to specify what a person can do. When you're in a provider environment, you would definitely want to go ahead and give each user only access to their own tenant. Okay. Tenant is the container, which essentially you want to segregate or separate, and thus you would ensure that tenant administrators are configured. For each tenant, you can have their own tenant administrator, and then for each tenant, you can specify, does the administrator have read-write permissions? Do they have read-only permissions? What can they do within each tenant? You can even narrow it down. So we saw how we would build a user. The user that I showed you was a local user. So when you're adding a local user, you would be asked to specify, choose the domain, and choose the role. If you're adding remote users, you'd be specifying the domain and role using AV pairs on these servers. Okay. So we'll take a look at the options available in this particular diagram. They're actually showing you that there are multiple domains. There's one called all, there's one called management, there's one called common. Those are three, shows you their system defaults. And there's one called solar and wind, which they've created. A domain is like a tag, which then gets associated to a tenant or multiple tenants. So if you give the user access to the tag, you're basically saying This tag, if it's associated, suppose I associate this tag solar with tenant called pod 10 and a tenant called pod 11. When I give my user permissions or access to Solar, the role that they get is for these two tenants. Okay, so a security domain is nothing but a tag which is kind of associated with other objects in your management information tree. So you can tag a tenant with a security domain, but within the tenant, you really can't have any other object tagged with a security domain. You can tag your VMM configuration, which is virtual networking menu. You can tag those with a security domain. Okay, so we saw the three default ones. All, that's the entire fabric. Infrastructure is the infrastructure domain or the infrastructure tenant. And then we have the management, which provides access to the management tenant. Example, a local user. Right there shows you user assigned to the domain all will have full access to the entire system. User assigned to the tag called wind has access only to the tenant wind. User assigned access to the tag called solar has access only to the tenant called solar. User assigned to the tenant common or the tag called common. And this fabric or infrastructure, you would have to be assigned the domain all. Okay, so if you've got to do anything on the fabric menu, you should be assigned the domain all. Else, you're only restricted to that particular tenant. There are different external providers that you can choose. In fact, when you look at the admin menu and go to AAA, you would see, let's show you that. You're on AAA and you look at authentication. And you can see we have AAA LDAP, Radius, TACAX, SAML, which is an XML-based security account management, RSA-based. So we actually have multiple options. Okay. If you plan to use, for example, any of these external providers, you're not adding your users here. So you possibly cannot add their domain and their roles in here. And that's when you would need to configure attribute value pairs. This one just shows you, it says Cisco AV pairs should be configured on an external authentication server. You have to go type in shell : domains equals the domain slash the read or the write or permissions that you want to give slash the role. Okay, to each user record, you'll have to configure AV pair on the appropriate server. That will specify, so you basically have this format, shell : domains equals, you get the domain name, slash the read or write, /the role. You can pipe it for configuring more roles. So that's something you'll have to do on the external server. And this one just shows you how you go about adding the radius provider. That's what this is showing you. Go to your radius tab in that particular screen. You can add your radius provider. DNS is functioning good. Host name is fine. The key to connect to the radius provider. And then, of course, you can change the timer there, timeout, retries, which EPG does it use to communicate with that radius provider. Do you want server monitoring? Do you want the server to be checked using some form of background keep alive? Not really keep alive, it actually, APIC tries to log into the radius. It's not just pinging it. It's not just doing that. It's trying to even verify that it will do a test verification. If you enable it, it will ask you for an account and password to do server monitoring. After you've done that, you should actually configure what is called a login domain. A login domain is going to ask you saying, hey, give a name, optionally a description, and which realm. Now, realm totally means this word realm. You get to specify, but be radius. Or the realm could be LDAP, or the realm could be TACAC. And then once you choose the realm, you choose the provider group. So if you choose radius, you should pick the providers who have been grouped together. You can create what's called a provider group. Now, right there it shows you remote users. I'm going to presume that this is trying to say that when you log in as a remote user, hopefully your radius server, based on the user information, so here's APIC, suppose it's user 1, APIC sends that information after verification and sends the password, and radius would respond back with the domain, the read write, and the role, I'm going to say. And that's how the user is authorized. So your radius server is propagating those privileges back to the APIC controller. Okay. If you're doing with Active Directory, it's actually easier. You don't need to configure AV pairs. So if this was Active Directory, Cisco has made it a little easier for AD. And suppose user 1 belongs to a group A. In here, you can map group A to the required role and the read write. So all the server does is specify the group of user A. And then based on how group A is mapped, which role and permissions, the user 1, not user A, the user 1 is authorized. That's only possible with Active Directory though. With all other products, you would actually have to go with configuring AV pairs for each user. Next, we move on to a little bit about monitoring this system. Where all does it send log messages, and how important fault management is in Cisco ACI. We have come to the conclusion all configurable as well as operational information about these switches is actually available in Cisco ACI, APICs, okay, as a managed object. So your APIC does maintain quite a detailed runtime view. It's constantly being told by the switch, so it actually has a runtime representation of the operational state of your switch. Okay. They're all stored in the APIC as managed objects, so you basically can see you will retrieve them through the GUI. Now, based on the runtime information that it received from the switch, the Cisco APIC will generate either events or faults and also audit logs. Okay. So that's why I say based on the runtime and maybe even based on some policy that you've created. So you may have a policy which says if such a fault is triggered or a certain event occurs, send a system message to a syslog server. Okay, APIC would generate false events and audit logs. I will display the error messages in the GUI and the command line regarding whatever user action. So I did mention that you can even, for faults and events, you can tell the APIC to trigger sending a message. Now, lastly, it says it's proactively monitoring your system, the entire fabric, without even having to depend on a third-party utility. It's actually gathering statistics from your fabric, and then you can proactively monitor it and trigger or send a message based on some thresholds that you have configured in the policy. You may even create monitoring policies for what purposes? Analyze trends. Now, faults in Cisco ACI, they go through what's called state transitions. Okay. So they also appear as managed objects. In fact, being Thursday, time for you to start looking at the fault of every object in your tenant. It's time. Okay. It raises errors. It kind of even points you in the right direction. So a fault record object is created in what is called the fault log for every fault. This is a dedicated branch of your tree. The fault transitions through these stages. The severities for the faults could be critical, major, minor, warning, information. Now, of course, it highlights when the fault is created. Soak time is a timer which you can change internally. There's a timer where it's saying it is waiting to see if this fault goes away. So after the soak time, it reaches its target severity. So it might just be a minor error and it waits for a few minutes. It doesn't clear, transitions to maybe a major, and it remains in that state. So unless you fix the issue, Okay. Now, if you fix the issue, it actually goes ahead, it changes its states to what's called raced clearing. You can see that in the fault window, like we transition to the state. Okay. That's the raced clearing. As soon as you go ahead and you fix it, it'll go ahead and change its state to raced clearing. It stays there. It's still saying, I am just waiting, okay, during this interval to see if this fault returns or not. Okay. If it doesn't return, it's moved to this state. And then during this time, it is considered retaining state. Oops. So the minute I go to the fault window, once I fix something, I'm always looking for retaining state. By the way, retaining state is for an R though. It's a long time. The default is an R. So it essentially says your fault is fixed, but I'm still here and I'll get deleted. So it's purged, you can see. Now, if you go to the fault window while its state says retaining, if it go there and you look at retaining state, you have in the fault window an option to acknowledge a fault. You cannot delete faults. Like it or not, you cannot delete faults. Okay, you have to fix the condition and then the fault has to clear itself. So you cannot go and select all the faults in your APIC and say, I want to delete it. No way. So it has to delete itself. Now, if you go and acknowledge while it's in the retaining state, it will delete right away. It doesn't wait for this 1 hour interval. But if it's in any of these states, you go ahead and acknowledge, it's going to stay acknowledged. I mean, it's going to stay in the raced. Okay. Even if you're here and you say acknowledge, it's not going to get rid of it. Acknowledge is simply saying, oh yeah, I've seen it. That's basically what the intent of acknowledge is. I've seen it. Except when you acknowledge while it is in retaining state, it's equivalent to saying, okay, please delete it off of my screen. I've fixed it, so please delete it. Soak time and clear time is 2 minutes, I believe, by default. You can control these. Yeah, it's 120 seconds. And this is an hour, so it's 3,600 seconds. Your possible fault severities would be minor. Okay, start with warning, minor, major, critical. And then, of course, this informational. What's an audit log? An audit log keeps track of who logged in and so logins and logouts as well as modifications that were made. Okay. Event logs, the system generated events, they're usually for monitoring purposes, link going up, link going down, starting and stopping some protocol, some new hardware component was added. So Event entries are not deleted. You cannot modify them, sure, but they're not deleted. They are deleted by the size. That means you have an event log which reaches a certain size. It deletes the information in the event log. It wraps over. Okay. And this example, it's showing you that event rules are similar to fault rules. This shows you there's a process there that's shown as number one. It detects some, I don't know, some kind of fault. So you can see it's notifying a process called EFM. And that's happening on the switch. Okay, so if you look, that's why it's actually showing you this is happening on the switch. EFM processes the notification according to the rules that are defined. Fault rules. Okay, so it processes that event or fault according to the rules that are defined. It does, remember, every switch also has a model, so it creates an instance there. Every switch has its model, creates an instance of that fault, and then it notifies the APIC, or should I say the APIC is collecting information, so it notifies the APIC. Or maybe I should have shown you notification done here. They already have that. It's notifying the APIC. Or if you have a SNMP or a syslog server or a call home server, the switch triggers directly, not through the APIC. The switch talks directly to the concerned syslog or SNMP destination or call home. I was getting a little upset seeing I'm going to show you, or let's see, something else. My system health is down to 96. Let me look at my tenants if they're all good. I thought I saw a tenant lose. Yeah, at some point, some errors were causing my tenant scores to go down. Right? So if you look at any tenant, oops, sorry. That's got its health, and you can actually scroll down and look at health information. And I do have some, I would say, false, and I can click on it, takes me to the fault tab. Okay, that's not the only object. If you look at any object, there's a tab called health. It's a score which keeps reducing from 100 as and when there are some errors or faults affecting that object. They have a secret recipe for it. They don't reveal that. They just understand that it is influenced by multiple factors, like they've shown you here. Could be the state, it's an interface, it drops increasing. Maybe there's too much latency for an application. The capacity of a particular, let's say a switch, its TCAM's capacity is reduced. So many factors influencing health of each object. The closer it is to 100, that means it is perfecting or it's working perfectly. You can see the overall fabric health. You can go ahead and look at each switch health. You can look at each application health. You can look at the layer 3 connections health. Each and every one of them has a health measure. It's some predetermined weighting algorithm that they've used to give these numbers. So system messages, you would be able to configure, send system messages to external destinations like a syslog server, SNMP management station, or even to a call home via email. Any fault or an event, the switch can be configured to send these messages. The messages would have this format. They always have timestamp, the source, like whether it's the APIC or a leaf or a spine or whatever the switch might be. The facility is usually in uppercase. Okay, it could be a protocol, it could be a module, severity level, mnemonic code, a number which uniquely identifies that message, and then of course a little bit more description follows the code. We do have the option to gather some statistics for monitoring purposes. There are some which are already configured, some monitoring policies which are already configured within the system. They are fabric-wide policies. They are 4 by default, and then you can create your own. You can create a fabric-wide policy which applies to all tenants, all the fabric objects, all access objects. You can create a policy which has a scope of only fabric. That means it only involves fabric-wide is everything. Tenants, switches, line cards, chassis, fans, everything. When you say fabric only, you're basically specifying the switches, the cards, the fans, the physical switches themselves. Tenant policy is configured within a tenant. EPGs, application profile, and so on. You can monitor for those. And then access. Oh, I want to look at an access port, monitor an access port, or a fax. Okay. So in this example, they're showing you how you can go into the tenant under policies, this monitoring, where you can set up monitoring policies on your own. There are 4 by default, 4 classes of default monitoring policies. There is one which is monitoring your fabric and access infrastructure, the fabric as well as the access ports. There's one which looks only at the fabric hierarchy, one which looks only at the access hierarchy, and one which looks at tenant hierarchy. You can override these, you can configure your own by configuring a specific policy The policy is going to go ahead and ask you, hey, how long do you want to? So right here, when you configure the policy, it's going to ask you, hey, tell the how long it should retain information about the collected statistics, where should it send it, in what format, should it send notifications to call home, SNMP, syslog. And for false evens, you can specify the level. Okay. Net flow, what is net flow and why do you use it? What's net flow? Why do we collect net flow information? Is there a particular reason? Felipe is the only one who uses net flow here. Okay, it's probably used to analyze your network, maybe using it for planning, maybe using it to optimize your flow, maybe using it to increase the security. And of course, it is away from your trend. You might even be able to determine some security breaches. So let you collect your network traffic information. Okay. You specify, right, what it should collect, maybe packets that match these certain values, collect information. That's called the flow information. And then you specify where it should export to. So this one, it basically ties these together. So flow and statistics is specified under record policy. Export policy specifies the destination and the net flow format and so on, or the version and so on. And then these two are tied together or associate to each other by using a net flow monitor policy. It kind of is like the container which basically holds the relationship between the flow statistics, not statistics, the flow information and the destination where it should be sent to. You can go ahead and define net flow monitor policy per interface basis if you want. Okay. And depending on the type of traffic, whether it's IPv4 or IPv6 or just layer 2, you can enable different policies. So here, it actually shows you the net flow monitor. You can create the net flow record ahead of time, and as well as the external collector ahead of time. In that case, you basically just select them in this window. But if you haven't created a flow record or external collector, you can also choose to have those appear in the same window once you start creating the monitor. So if I want to go ahead and configure it for my access interfaces, I would go to my Fabric access policies, interface policies. Within that, I can go ahead and create my NetFlow monitor below the folder called NetFlow. You can also do that on a tenant. You can actually go to the tenant and then the tenant policies. When we saw tenant policies for monitoring, there's also a folder called NetFlow where you can configure NetFlow monitoring, the tenant basis. So here, it just shows you the field for the NetFlow record. And you may see that the flow record needs a name, needs the parameters like match based on what. And okay, so match parameters. What are match parameters going to be? What would be an example of match parameters for a NetFlow record? I could say match based on source IP, destination IP, source port, destination port, protocol, VLAN, type of service. Okay. A flow using match property. That would be the match parameters I can choose. And you can specify what to collect. On the collector, you'd have to specify destination IP. That's a required field. See, the red ones are required field, right? The other ones are not highlighted because they have their defaults. Destination IP and destination port. On which port the NetFlow collector is listening. You can optionally specify a source IP, the NetFlow version. In fact, you can't see it, but it's asking you version 9 or version 1. It's asking you for the version. Okay. If you have to specify whether it's connecting or sending to the NetFlow connector, connecting through a particular app EPG or through a layer 3 connection. Okay. And of course, we'll also ask you about the VRF. Now, Cisco introduced titration analytics in version 2. The ASICs that are there in the switches, they can either collect flow information using NetFlow or using titration analytics, which is a lot more deeper. Usually, titration analytics is something you might do if you either purchase that application or at least have titration light. The good thing about titration, it actually lets you arrive at a model for your application and the EPGs and the contracts. That's the purpose of the ASIC and the hardware. So the same ASIC is used for both, so you cannot enable both at the same time. By default, this ASIC is used to explicitly specify that it is to be used for titration analytics. So if the APIC pushes an update to the switches, once you configure NetFlow, it's going to push this. Well, this feature selection tag is going to determine if you configured NetFlow, but this priority is set for titration, the NetFlow is ignored. You can change this under Fabric menu. there's an option for fabric policies. Go to switch policies and configure the priority. Which of these is used for collecting flow information? Well, NetFlow with virtual machine. Now we know that it supports virtualization with multiple hypervisor vendors. Okay. So you can go ahead and provide very explicitly, notice this is NetFlow Exploiter, particularly for virtual machine networking. That means your exploiter is a VM. Okay. So the policy for VM networking shown here, you would actually configure this in your virtual networking section. You got to configure it there also. Under inventory, you've got to go ahead. This is under virtual networking. You've got to configure the. So the first thing, this particular screen is actually not from virtual networking. This particular screen is under Fabric access policies, the same place that we went back here to create the flow record. Okay. This is under Fabric access policies, interface policies, and then you go ahead and specify. In the same place, you have actually an option under Fabric. If you look, access policies, we can take a look there. And not here. I think it's under policies. See if they put it under interface or, yeah, right there. The one for VM networking. This is the screen they've actually shown you. If you had to configure for VM networking, you pretty much have to configure it explicitly for virtual machine. Okay. Then once you do this, you got to consume it under a VMM domain. So you've got to do that. They've actually not shown you that under virtual networking. Select your VMM domain. Let's pretend there's one. And under policies, somewhere I should find NetFlow. My screen is a little disastrous, but I should be able to find NetFlow somewhere. Okay, it's got stuck. I'm doing a great job at this. Resolution, not perfect, so have trouble, but I forgot I should be on the V switch. Yeah, right there. Okay. So you'd have to configure it in the VMM domain. And then also, when you go ahead and enable associate EPG to the VMM domain, there is an option where you have to enable for NetFlow collection purposes. And that brings us to the end of that particular chapter. Okay, we're going to move on to Boyd. I don't see why you should be able to ping from a VM to the leaf. I don't see any contract allowing you to do that, so I'm not sure why you're doing that.
No, it wasn't pinging to the leaves. It was from the VM. You have to putty
You
into the leaf,
now
and it wasn't working.
you're supposed to do it from the student desktop. You
Yes.
can't putty from that VM.
Well, no, that's what it said to do. Or no, maybe I was doing it
Not
desktop.
at SSH. No, I don't think they
Yeah,
had
no,
that.
that's why it was failing then.
I don't believe they had any kind of permissions or anything set up between the VM and the leaf switches, so you shouldn't have been able to. Okay, let's get started with the next chapter. Well, this highlights all the different methods of access into the APIC. We can definitely use the API, which we know. REST API, you have actually only used Postman as an access method. There are several other REST clients. Even a simple Linux platform has a command line called curl. Every Linux platform has a command line utility that you can avail of. Curl, command line URL. So we can use the API, we can use its built-in GUI. Command line, of course, to configure the APIC, do not mistake the command line. You cannot configure the switches. So CLI here is read only. The APIC sends the configuration. It's the single source of truth. We saw in the last chapter that you can send your system log messages or your events notification to any of these destinations that you specify. Okay. Primarily, a lot of people have used a GUI. I would say that was the GUI and programmability were the two options. Later, once they switched over to providing an NXOS style command line, it's available, and anytime you look at the configuration guides, it shows you the instructions for programmability and the GUI. You pretty much don't find the command line options. You pretty much have to learn it yourself by playing around with it. So, of course, if you log in through the GUI, you cannot see the managed object tree. The only way to see it is using the utility we've used earlier. That would be the viz array. We've seen that earlier. When you're within the APIC, you can right-click on your switches and launch SSH. So if you're within the APIC, I am unable to launch SSH right now because we haven't enabled that feature to launch SSH. So you can in your topology diagram, so you can see the topology diagram in your Fabric inventory. And you should be able to right click on the switch and do a launch of SSH, but I cannot. Reason is it's not enabled. Okay. It says to ensure that admin state of SSH access via the web. That has to be enabled. So I pretty much have to go to the Fabric policies and specify the pod policies. So in here, I've got to go through the pods policies and change the management access to permit SSH to be launched via the web interface. Starting from 1.2, the command line has become the NXOS style. Prior to that, it was the bash command. It was quite difficult. I was not too happy using the bash command line. Now you can go to the default command line and pretty much say, hey, show me endpoints, show me the VLANs. Okay. On the spine and leaf switches, you can always resort to using your iOS or NXOS. Show endpoint detail, show VLAN extended. Then if I do want to switch over to the bash, there is a way to do it. The virtual shell, which is the deprecated shell access to the switch. And it basically is taking you through navigating this environment using the object model. For each line card, I can go to the shell. Line card shell would be virtual shell in the line card. That will let me check the line cards processes and forwarding tables, which are specific to the Cisco ASICs that we have in there, the leaf and the spines ASICs. If you have a first generation switch, you're likely to have Broadcom. You would access the Broadcom shell by actually typing in, if you have first generation, that would be Broadcom shell, it's BCM shell hardware. But you see the processors on the Broadcom ASIC. So, and you can actually directly run a process on the Broadcom ASIC. If you just, even if you don't go into the shell prompt, you can just say, we shall BCM shell HW, and then run the process or the command that you would directly write to run. That would mean you need to know the commands that you have to run. That would mean you need to probably attend the troubleshooting class a little bit. So here's how you launch the SSH. Of course, I've got to enable for it under pod policies, management access. I've got to specify that it should be enabled. Here's how you get to the command line. Right there, it shows you line card, command line shell, Broadcom shell. And next is information about the management information tree. Keep hearing it. Why do you keep hearing it? It's actually a very crucial component or a crucial player in the programming world. This is known as distributed management information tree, actually. It's not just, notice that lowercase d on top, because the objects that are these branches, they are all spread across multiple devices. Remember, APIC sees your entire fabric as spread across a virtual chassis. In the virtual chassis, it sees the leaves as line cards, the spines as what we call fabric modules. So this is your source of truth. Every change that you configure, every operational information, anything that you, in any time you interact with, I believe, it's always interacting with this tree. Whether you're programming it or command line or GUI. You can go ahead and use VisArray, use that utility. Every object in this fabric will have its own errors, problems, which will all be programmed or it will be categorized in this tree somewhere. Query an object in the tree will give you all the related information. That shows you with array would be a smart move. Launch it. You can either type in a distinguished name, don't know the name, type in a class, don't know the class, verify it in the command line or in the API inspector. Sorry, verify it in the GUI. Command line is a little difficult to verify the name of the class or name of an object. So you do have this array. You can browse via the shell, a command called managed object query. That's a direct command line command. You can use your REST clients, iCurl, which is a REST client on your leaf. And of course, we have the Cobra Python SDK, which can go ahead and let you view the tree. That shows you, you can go ahead and identify the type of query you want, whether it's a class level or a object level. Class level would need you to specify the class. Let's look at the name of a class. For example, if I go here, I'm going to go ahead and say, show me debug information, which is actually show debug information. And let's just click on this. Don't know if you can see this. Way down at the bottom, it actually tells me the class model. It says model is model definition is FV tenant. That means it belongs to the class called FV tenant. It's in real fine print. You can see it. It's at the bottom of the screen, purely displayed because I said show debug info. And then it also shows me the distinguished name in square brackets right here. It says uni/tn-pod 11. Okay. You can also see the distinguished name right here in the pipe. If I click on right there, uni, right after the pipe symbol, uni/tn-pod 11. Okay. Now this just tell you that you can go ahead and do a query based on the object name, just know the distinguished name. And of course, you can view the query through the command line or through your this array tool. Command line would be this one, mo query. That's a command that you would use, class-based or object-based. Class would say FV tenant in my particular example. So there shows you, highlight show debug info. Then you should be able to see the class as well as the distinguished name of the object. I mentioned you can also see it on the top, okay, in the address bar. You would also see it if you were to right click on it and save as. Notice how the right clicking, saving it as an XML file. If you notice in the XML file, it's showing you the DN, distinguished name. Okay. The tools that we just saw. With array, managed object query, and curl. These are the ones. So highlights of what we just discussed. The DMIT, distributed MIT to be precise, it holds a lot of values. Okay. So being able to browse through that tree can let you retrieve information. It can even give you statistics, can give you health, state of an object. Okay. And if you're using the command line, you can always do grep. Regex would be great. Okay. You can have grep search the file. So here we are. Main features to remember. There is grep and egrep. Also, you can look for specific patterns or fixed string. Grep can search through your compressed files. So this would be a great idea to use grep or egrep to search through output. Array would be another option. Log in, launch it, log in, and then you can specify you'd like to search for a certain class, or you'd like to search for a specific DN, or you can find the DN and look for its properties. And then you can also look who's the parent of that object, who's the child or any children for that object. You can go ahead and find that information through VisArray. Here's an example showing you exactly that. This is a bridge domain. Or no, it's actually showing me this endpoint is a part of this bridge domain, and I can see that it shows me the left and right arrows. In all these cases, the less than and greater than. Less than is to say, go back to the parent object, and greater than is to say, show me all the child objects of this particular parent. Now, another tool on the APIC, you can run it through the command line. First and foremost, get the help. moquery -h gives you the help of this command line utility and allows you to query this tree using the command line. So output is quite easy to read. You can even grab this output if you need to. Okay. There it shows you not as fast and efficient as VisArray. You can use the H help feature, and of course it shows you the help, and it shows you what each of these letters stand for, so you can specify filters also to filter down the output that you would like to retrieve. Here's one. Let's go ahead and run the mo query. Look for the class. C is class. A class name is fault instance. F is a filter saying look for instance code F0467. Okay. And of course they have egrept it. Show me the concerned DN. Another one right there with an egrep. Show me the class for, it's actually doing a class of VLANs. Actually looking for encapsulation VLANs. So that's the class. And of course, here it's looking with egrep, particularly for the VLAN keyword. But this egrep is narrowing it down more. It's saying, I want to look especially for VLAN 120. Another one shows me that this VLAN is probably learned through an layer 3 external. Looks like it's coming in through an external connection that you configured. Okay, there's a tenant called OSPF and there's an external configuration in there. So it's actually showing you that this VLAN is probably used by this layer 3 connection. Another utility to navigate the management information tree would be curl. It is an open source application available in Linux platforms. Stands for command line URL. URL-based network requests can be initiated from the command line. So you can actually go ahead and execute curl commands to the REST API. iCurl is kind of like a wrapper of curl that is resident in the APIC. Okay, so it shows you it uses iCurl as a wrapper. It doesn't prompt you again for authentication. It uses the same token that was assigned for your SSH session when you initiate iCurl. Okay, so it shows you which ports are being used. Curl is from any Linux system. And iCurl actually gives you a little bit more filtering features than curl does. Because it's specifically a wrapper that is for, here you can actually see it's getting a fault record. What is the fault record number? This filter actually tells it that we want fault records of F0467, anything created greater than this particular date. I would argue that it's difficult for you to arrive at these filter values by using even the help, and usually that's where this particular utility comes in handy. Visare. You can actually, on the top of the Visare utility, there is an option to specify your criteria. And then there is a button saying display the URL. It will show you the filter criteria, which you can use, copy it into any REST or even the command line application. That would be your access of the API. Next, we look at the VLAN. Okay, so you're going to go ahead and try to figure out why two endpoints are not able to communicate with each other. The first thing I would start off with is, do the endpoints even show up? I may look at the endpoint table in the proxy, which is the spine, and I look at the endpoint table in my leaf switches. Okay. So I may want to navigate or investigate the forwarding table. And if they are in there and they still can't communicate, I would probably narrow down to the contracts not being correctly implemented. Or, of course, the next thing I would look at is the VLANs that are being used by these endpoints. Maybe the VLANs are not programmed. Okay. So here it talks about VLANs. You should remember that ACI does not use VLAN internally at all. Those VLANs are used purely at the access ports. Once they ingress into the leaf switch, They are stripped off, but they're actually translated. The ones that you configure on the access ports are called the encapsulation or the wire VLAN. The one that is on the wire is also termed as the encap VLAN. So they translate these external or the encap VLAN. It's called the encapsulation VLAN. Once it's received, it actually translates it into what's called flood domain VLAN, VXLAN. You have platform independent VLAN. You'll see a lot of things that it gets translated to. This is usually done in the ingress switch. Okay. So I would first look at the encap VLAN and what it's translating into. That's something that you would want to verify. Okay. So first point, usually I see a lot of people don't realize it could be the VLAN has not been allocated to the domain. Physical domain, routed domain, whatever, you've got to make sure the VLAN pool is allocated. You should verify, are we using VLAN or VXLAN? One of the commands that we tend to always use on switches would be show VLAN. So you can see, you can at least see the translated VLAN. Show VLAN extended would show you how those encapsulation VLANs are being translated into the internal VLANs. So internal VLANs would show up. In fact, if you do show VLAN, it actually shows you the internal VLAN. It doesn't show you the encapsulation or the wire VLAN. You'll have to do show VLAN extended to see the mapping. I have an interesting article which actually tells you about how it gets translated into a flood domain VLAN or platform independent VLAN, and of course internal VLAN. You would see that I cannot trace it here because we don't have too much hardware to be able to, and we are stuck with virtual machines, very limited number, 2 hosts, that's all we have. And I can't move cables around, so it becomes a little difficult. I cannot move my virtual machines either. I don't have access to move them around either. It becomes a little difficult, but otherwise, we do have a troubleshooting class where you actually see how the VLANs get mapped, and that's a very interesting topic. I would encourage you to take that class so you can actually determine. But before you go there, this is show VLAN, by the way. That's not the real encapsulation. This is actually an internal VLAN that it's being mapped to. And if you do show VLAN extended, it actually shows you the encapsulation VLAN. When you go into the line cards, you can actually shell commands. You can see the flood domain VLAN and other values, platform independent VLAN. Those are the values that get translated into. The endpoints themselves. We're going to see how it's learned into the database. Remember, this is your entire switch. And they've actually drawn a distinction between the supervisor or your CPU and your line card. So that's a switch. It's a leaf switch. It could be a 9300, which is not even a modular switch, but we still use the term supervisor because we're kind of saying, hey, that's the CPU, the central processing unit. So we have an endpoint manager running in there. So you notice that process is handled by the supervisor. It's running on every leaf. It eventually learns about, so here's how your traffic is coming in. This one's going to learn about the endpoint, give that information to the endpoint manager. So the endpoint manager is running, it's responsible for learning the endpoint information, IP or MAC address. It builds the table. It builds the endpoint table. If it's receiving over the Fabric port also, it's going to learn the endpoint manager. By the way, that's not the Fabric port. I shouldn't have drawn it there. But it's coming in on a Fabric port also. It's the endpoint manager, which is responsible for maintaining your endpoint table. Okay. Endpoint manager is responsible if you had a VPC sync. The type of message queuing is called zero message queuing. Programmers will be able to tell you what exactly the good features of zero message queuing framework is. So notice it's also maintaining the object tree. And that means it's responsible for also informing the APIC about any endpoints. Because this object tree is then processes running which communicate with the APIC. It's also responsible for communicating with COOP protocol. So it can use zero message queuing, inform the Council of Oracles. Is fine. The client, that's the endpoint manager client, it handles making sure that endpoint information. So keep in mind, this one learns about any entries, let's say through the ports which are Fabric connected. It's got to program the information into the global station table in the line card. This one is responsible for handling the programming in the hardware. Handles aging out of entries in your hardware. So also it learns. So learning notifications in hardware is done by the endpoint manager client. So where would you first check? If it is a locally connected device, I would probably say the endpoint client has learned about it. That's a line card. Line card is closest to the endpoint if it is a locally connected client or locally connected endpoint. Now, if I go ahead and do show endpoint on the APIC and I see it, I am happy that the endpoint is learned. What I might do is, where did it learn it from? Is it a local one? Is it a global or remote one? I might repeat the command again just to make sure the endpoint stays stable. But then on the leaf switches, okay, I could go ahead and say show system internal endpoint manager endpoint followed by an IP or by a MAC address. I could even do on the APIC, by the way, other than a show endpoint, you can even do a query, a managed object query. You specify the class, whether it's this class or IP address class, and then you can specify the IP address with the filter. If you want the filter, don't want the filter, you can go ahead and that'll be too much to see. So ideally use a filter. On the leaf switches themselves, there is, of course, this command as well as one more for verification of the endpoint manager client process. So on the line card, it would be, I would do V shell line card. That would go into, and then it would be show system internal endpoint manager client. Okay. And then the word endpoint and the IP address or the MAC address. So the only difference between this would be this command is on the command line, that's the supervisor, CPU. And then on the shell line card, it will be the exact same command except on the line card, it's the client process. This command will show you everything closest to the hardware because if you notice, it closest to the ASIC. Okay? It shows aging timers, learned source, and so on. And if I were to go on the CPU, it shows me details like the internal VLAN. Okay? So, list of commands. So on the APIC, you can go ahead and say show endpoint, followed by the word IP and then an IP address, or show endpoint followed by the word MAC and then the MAC address. Similarly, show endpoint on the leaf switch. You can go ahead and do that. Okay. Show endpoint detail can be done on the leaf switch. Okay. So show endpoint detail will show you your external encapsulation as well as the VLANs that is translating to. You can go ahead and also look at a little bit more detailed information, internal endpoint manager endpoint, and then on the line card, you can say internal endpoint manager client followed by endpoint. Here's an APIC. Shows me the physical encapsulation VLAN. This command will show you not only the ones that are learned, it'll also show any which are remote, the type of interface that was learned through physical or VPC or a tunnel interface. In this case, it's a physical interface. So, of course, that means it is a local entry. You may want to run it again just to make sure this entry is stable. I could continue to follow this entry by also issuing the command on a leaf switch. Anybody remembers how virtual machine movement is handled? There's something called a bounce timer when a move occurs because of a GARP or a reverse ARP. The hypervisor sends it. And the original switch is going to have a bounce timer, something that we had discussed probably on Monday. Virtual machine movement. So you can actually see bounce intervals. If there is a bounce tag on one of the leaves, it'll actually show it to you. It will show up. Okay. So when I'm on this one, for example, show system internal endpoint manager client followed by an endpoint, and I specify a MAC or an IP address. And if this particular VM is actually moved to another host, which is that means a different port, a different leaf switch maybe, it will show you a bounce value. Default intervals. Remote endpoints are aged out in 5 minutes. Idle remote endpoints are aged out in 5 minutes. So that's the default aging timer. Local endpoints are typically aged out in 15 minutes, but it doesn't age it out like the remote ones. Local ones, what it does is about, I would say, while 3/4 of the timer has passed, which means right after 12 minutes, your sleeve will actually send ARP request to that endpoint. The leaf goes ahead and says, hey, I'm going to proactively check with this endpoint. If it's locally connected, why is it so idle? Why has it not been used? So essentially, it will send these after 3/4 of the aging interval. The default aging interval is 900 seconds. So essentially, I'm going to say that's 15 minutes. So around the 12th minute, it's going to go ahead and start sending ARP messages to the endpoint to see if there is a response. It sends 3, no responses. It assumes that the local endpoint is dead and it ages it out. So this is an APIC. You may also see you can issue the same command on the switch itself. Shows you details about the endpoint. In this example, they are discussing an environment where a VM has actually moved. So, of course, guess what happens? Something moves from here. According to the spine switch, I don't know what I should call this endpoint. Let's call it endpoint 1. Originally, endpoint 1 is on leaf 1. And of course, in here, in the local station table, you probably have endpoint 1 on 1/4. It's a move. This one sensor. COOP, it shall all be cap, not lowercase. But that's going to go ahead and say, hey, you're not good anymore. It's moved to leaf 2. So the spine actually sends a message to leaf 1 saying, bounce to. So if leaf 3 has cached in its global station table, endpoint 1 is on leaf 1. And you would see that when it sends it, it's going to bounce off and then make its way towards leaf 2. The bounce entry is 630 seconds. You can fine tune it, but that's the default bounce entry. Okay. So what are we looking at? Leaf 1 has the entry in its table. This is before the move. It's from the ASIC itself. You can see this is on the line card, the prompters module. And it shows it was learned on Ethernet 1/4. Well, after the move, there is a flag, bounce. It's learned that this entry is reachable through tunnel number 5, and it also shows you the timer left for the bounce. This is on the very same switch, endpoint manager client command being issued, and it shows you the bounce timer. The GUI tool that helps you quite a lot. It's on the operations menu. It's called the endpoint tracker. It'll show you any virtual bare metal endpoints. You can actually tell it saying, please track from this IP to this IP, or this MAC address to this MAC address. Okay. It'll show you all the connections. Like in this case, it's actually showing me the endpoints where they're connected. That's the leaf. These are the two spines, and I can't see very clearly, but it does show a source endpoint and a destination endpoint right there. Looks like both are on the same leaf in this case. Okay. So this is something you're going to be running a lab on. Hence, I'm not showing it to you, but you create a session, you can tell it a source IP, a destination IP, and then you can navigate and see which contracts are being used. You can do trace route, you can see any audit logs, even look at more detailed atomic counters. Optionally, you can also choose to enable span. So before you get to the screen, the first page would actually ask you saying, enter the endpoints, source and destination. Or you can say, hey, just track this particular endpoint MAC address. And then pick your endpoint. If multiple show up, because they might be the same IP address space in multiple VRFs, you've got to keep that in mind. Pick the one that you'd like to track. Anyone using ELAN? Embedded logic analyzer module. It lets you look inside an ASIC, diagnostic utility that Cisco has been providing on quite a few platforms now. It looks inside the ASIC. It can capture, let you view the packet. You can tell it to match some criteria from a certain flow of packets that are being processed by the APIC. So ELAN is actually in the forwarding pipeline, and it lets us capture packets in real time without any negative impact on performance or your control plane processes. That shows you how you would have to configure for ELAN. You would have to specify the ASIC instance when you initialize the ELAN, the data path, which is the pipeline, ingress and egress, that would be your data path. You'd have to specify you want to go ahead and configure for ingress or egress. You'd configure a trigger. Trigger is based on different fields inside a packet. You'll tell it to look for certain fields. Then you arm the trigger saying, when it matches in a hardware, you'd like to get the information. Trigger is triggered, you can see the report. No one used it? iOS XEs, iOS XRs, NXOS, they all have ELAN. ELAN. Another troubleshooting discussion. Your layer 3 out. This is one big giant data center. If you have multiple tenants, each tenant might have their own layer 3 connections and policies. Okay. If you're thinking about it from a traditional perspective, it will look like multiple tenants is definitely multiple VRFs, so you'd have to relate it as one big giant router with multiple VRFs. That's what you want to relate to. As I mentioned, when you pair with a non-ACI layer 3 device, you've got to ensure that the routing updates are distributed into the ACI Fabric. So we have to have a route reflector configured and an AS number. That's a system-wide setting. Configure 1 or 2 route reflectors for multiple sites. In other words, multiple PODs, pods in each site. You may want to configure a route reflector or at least 2 route reflectors for both. Only the spine switch can be a route reflector. Now, technically, if you think about IBGP or a BGP, needs to have connectivity to, you've got to configure every other neighbor device manually for it to configure a mesh with every neighbor. So to overcome that, of course, we are not using such a configuration. IBGP is made scalable here purely by using route reflector feature. Your clients, your leaf switches are your route reflector clients. AS number could be anything. Okay. You probably might use a private range though. Border leaf switch. Border leaf switch is the switch which is, or the ACI switch, which is essentially connecting to the layer 3 peer. The first thing I want to check after configuring the route reflector is, do we have peers? Okay. So in this particular diagram, they're looking at the VRF, which is the system VRF, looking at the BGP sessions on VRF overlay 1. Every leaf has to have a peering session with my spine. This example shows me that we have 2 peering sessions. I'm going to assume we have 2 spines. Because if you notice, I would probably go with 2 route reflectors. I'm also looking at the this is a command we did on Monday, actually. It shows you all the switches in the fabric, by the way. That's what this command does. ACI diag FNV read. It gives you the switches in the fabric. So what they've done is they've just kind of showed you that these 2 are spines and this one is a leaf. If you look at the role, and of course that leaf is peering with the 2 spines. Just identifying that means those 2 spines have been defined as route reflectors. Well, there is no way you can look into the routing table and see the route distinguisher used. So we're going to be verifying it as part of VPN v4 Unicast. Can't see the route distinguisher used from the routing table. So here actually shows you an example of this segment 172.16.1.0. It's been redistributed into this VRF here. And of course, your border leaf is going to receive it and then redistribute it into your route reflector. And then, of course, thus leaf 3 receives it. So the only way you can verify the route distinguisher is basically the command here, the VPN v4. EBGP. Why this mention of EBGP? The early releases of ACI did not support EBGP. It was introduced in 1.2. So before that, it was always only IBGP. Because of EBGP support, of course, they had to add more features with every release. And of course, that means you can fine tune it for your EBGP environment. This is quite a scalable protocol, so Cisco had no choice, and a lot of people are using it all over, even within the enterprise. It makes it a good choice. Okay, so you might have EBGP already used, and your ACI Fabric is doing IBGP. Well, that just lists out the configuration requirements if you were configuring the BGP peering with your neighbor. That shows you with the layer 3 entity, you can use I or E, different AS or the same AS. See, this will be the configuration requirements, pretty much this similar to what we saw in USPF configuration. We did see OSPF, another scalable protocol used by enterprise networks. You can go ahead and fine tune its properties based on the type of area needed. Again, initial release only supported not so stubby area, but now, of course, it can be a regular area, it could be a stub area, it could be not so stubby area. It just has to match what your neighbor, your peer device is configured for. Configuration perspective, they're pretty similar to, or most of these routing protocols, when you configure them, you do have similar requirements. So for example, if you're doing OSPF, you've got to make sure you got the area ID is correct. You've got to specify the, something very important with OSPF. You've got to take care of the MTU, because MTU is exchanged in OSPF keep alives and the MTUs don't match. Then again, they would not form neighbor relationships. You've got to be careful about that. The example here actually shows you router, which is connected. Router B is attached to leaf number 3. OSPF protocol is used there. And they're going to be feeding it into a particular VRF, which then exchanges the routes with the rest of the network. I believe they have a problem communicating from loopback interface of router B, so they're trying to communicate from here, this loopback IP, to this VM 10.33.1.4, and it failed for some reason. So the first thing I would do is look at the configuration on router B. Okay, which area does it belong to? It looks like it belongs to area 13. Remember, if you have multiple tenants or multiple VRFs, I'm probably going to use VRF light on this end. So we're looking at the configuration, seems like it's area 13. Verified the router ID is configured as 10.33.254.13. That's the default router ID, loopback IP. Okay, so first thing I would do is check. See, that's router B. Check the area ID, router B, check the area type, broadcast, point-to-point. Okay. If those two do not match, OSPF will not appear. I had 2 students who don't have their area ID correct. Then when I'm looking at my border leaf configuration, by the way, this is the external routed network configuration, looking at the area ID, verify the type of area. Also, make sure you have the right interface type. So if you have, in this case, we're using SPIs for our OSPF. You see that? They're all SPIs. So on this configuration, make sure I have the right encapsulation configured for those SPIs. Something else you've got to match carefully. Right there. And I know why they highlighted it. MTU. It says inherit. That means inherit the MTU size from your SFP. Okay. So the default actually works out to be about 9,000 bytes. And the other end, I don't know if they showed us any particular configuration, didn't tell us, but on these, you might see they don't have any particular MTU configuration. They do have one here saying MTU ignore on SVI 876, but on the others, I don't. So if the MTU size does not match on both ends of the peering link, again, OSPF will not. That's not something just specific to ACI. It's actually quite a common issue. MTU has to match for OSPF to go ahead and form neighbor relationship. Something else, VLAN, in encapsulation VLAN. Make sure this VLAN has been assigned for use on this routing domain. Well, OSPF interface policies, you can go ahead and specify an interface profile and then configure a policy where you can control the priority, dead timer, hello timer. Just make sure those things match on the other end. Hello timer and dead timer also has to match. If you plan to use BFD for hello instead of the hello timers, you plan to use it, you should configure it not only here, but also configure it at the peer. Okay. You plan to advertise the subnet mask. You do have an option to ignore the MTU right there. You do have the option to set passive interface. The network that's going to be the external EPGs right here. That's where you're specifying the external EPG's name and which subnets are to be learned, are to be accepted. But this checkbox, okay, you also have to enable for external advertisement on your own bridge domain subnets. Okay. That's actually saying that we would like to have these subnets associated or advertised as part of the external EPG. You will need your own bridge domain. By the way, the EPG has to have a contract, so they're showing you a contract. You will have to associate your bridge domain with that layer 3, saying that the flooding domain uses this for routing purposes, and also ensure that your bridge domain subnets have that checkbox enabled. Yeah, on the border leaf, which is my border leaf in this diagram, back here, leaf 3, we're going to go ahead and do the regular OSPF commands. Verify the interface, get my area ID, my interface type, network type for OSPF is a broadcast, my hello, dead, wait timer. This is on the border leaf. After that, make sure the border leaf has seen its neighbors. As a broadcast types, of course, there is a DR and BDR election. So that's why it shows you that this neighbor, it has a full, and it's the DR. Full means its database is synchronized. I would then look at my OSPF database. The OSPF loopback will be the LSA type 1. Layer 3 out connected subnet would be type 2. The subnet that is connected, right? Back here. This subnet would be my type 2. Anything from here, according to this one, will be type 3. Any ACI subnets, any internal bridge domain subnets that you've enabled for external advertisement should appear in here as type 5. That means within OSPF, because those are learned via BGP, or they're not learned as OSPF, they are statically learned, they would be type 5. Okay, so you should verify your OSPF database for that particular VRF. These are the subnets on which you would have enabled advertised external, the bridge domain subnets. Well, only 3, we're verifying the routing table. These are, of course, the bridge domain subnets. Okay, notice the 33.1, the 33.2, and 33.3. They are considered static. They are the internal subnets. The ones here are learned via OSPF. And you can see the encapsulation VLAN on the wire there. The non-border leaf, that means this is actually a leaf which is not connected to that OSPF routed network. 33.1 to 33.3, they were all static, but it should show me the 35s are learned through BGP. And going back to my, I hope they have it in the diagram, we should be able to identify that these surprisingly, they put it as 10.34, and I never saw 34. It should be 10.35, I believe. Those are the subnets that we see. 10.35, I think, is what they're showing you. Okay. The 10.35.10, that's 10.35.10, 11, and 12. And of course, that's being redistributed to the non-border leaf as 10.35. So apologize, Cisco, I clearly made a mistake. I don't know why. This should be 10.35. I think this might be showing IP addresses on this end, but of course the subnets would be 10.35.10, 10.35.11, and 10.35.12. Router B is showing the internal subnets as type 5 LSAs. These are the ACI subnets. It's learned it. This is not a leaf switch. It's that external router. And of course, you can see that it has those also learned over the VLAN right there. It's on router B. Shows you a ping by router B. And things seem to be fine. Tech support. It captures your application log, your system and service logs, falls, even an audit log, debug counters, some other outputs I'm trying to think that are all bundled together into one file. That would be your show tech. It will be a single compressed tar file. You can export it off to some external location for sending it to Cisco maybe. So tech support is similar to the show tech command that you've used. It's a lot of copious amount of information from the system that's collected. So you can configure for exporting the tech support within the APIC to a certain destination. Configure a policy. That means you specify the transport protocol, which algorithm, how often do you want to configure or send this tech support information. So they are one of the policies in the APIC. You can schedule it for on demand or for a schedule basis. Destination could be to the APIC or to a remote location. Well, the size of the file will vary based on these criteria. So, do you want all leaf switches, which is the default, or just a particular leaf, all individual spine switches, or just a particular spine? You can control this. Right there, admin menu, you can see. There is, of course, the option to do import export. If you didn't capture that entire screen, it's one of the options, import export. You see that here. And you can specify your remote location right there for your tech support. That looks fairly straightforward. The this is tech support remote location. So here is how you configure your on-demand tech support. But be careful about doing the on-demand simultaneously from too many nodes at the same time. Okay, you don't want more than 5 switches together at the same time. There it tells you to choose your expert location, and then you can specify the source nodes right here. You can also choose a category, what you would like to be exported. You can be a little bit more selective. The switch itself, you can remove it from the fabric entirely, or you can actually remove the switch just temporarily, saying that I just want to not have any data forwarding take place. So more like putting it into some maintenance mode. So either way, if you're going to remove it entirely, you shouldn't have any data being forwarded to it, which means you shouldn't have anything connected to it. If you plan to put it in maintenance mode, understand that it will not forward any data. Now, in versions prior to 3, so this one's showing you what are the options available with 3 and later. Prior to 3, there were 2 options to kind of decommission your switch. One was, of course, remove from controller, which is still there. Okay. It'll completely remove the switch from the fabric, and the APIC and will no longer show up in fabric membership as a registered node. It will not show in your topology. Also releases any VTEP IPs that were assigned. This is supported in both modes, in prior to 3.x as well as 3 and later. Okay. Now, prior to 3.x, there was an option called decommission. And we would use it for maintenance purposes. It basically tells the switch not to send out any faults to syslog or SNMP. The switch does keep its node ID and its membership. Okay. And it would show up under what is called decommissioned switches. It does keep its VTEP IP also. In both cases, the regular decommission mode or in remove from controller, you cannot access the switch via its management port, and also its log gets cleared. Sometimes some people may just choose to reload your switch. Reload need not necessarily fix your problem. What happens is it's going to get rid of the entire configuration, clears it out, and then it will get the policy pushed to it by the APIC. So in version 3 and later, they kind of introduced this mode called maintenance mode. It is kind of more like a controlled reload. So you can see the switch does not remain in the forwarding path anymore. But, so in here, I couldn't access the management port. You couldn't actually log into the switch via the management port. And then you couldn't even access the log because you take it into decommission mode and it would clear the log. So that's not possible. So in 3, Cisco introduced the maintenance mode. You can see you can still continue to access the switch via management port. You can collect the logs. And of course, Cisco Tech would need that. Okay. This would be a good way to kind of see how VPC is functioning. You want to do a graceful shutdown of a peer. The maintenance mode is quite a nice thing. It's also known as GIR. It's basically saying, yes, the switch is there, it still has its IP, and you can still collect logs, you can still connect to it, but it's not in the forwarding path. Okay. Basically, deactivate all the protocols and the front mantle ports on the switch. Okay, so how do you put it into the maintenance mode? No, it's graceful insertion and removal. It's the same. That's how you put the switch into maintenance mode. Once you collect your log, you can always choose to reload it and put it back into production. That's an example of a use case for a switch to be put in maintenance mode. Seems like they have a fault in the fabric. You want to isolate that switch, so they go ahead and put it in maintenance mode so they can collect the logs and give it to your tech engineer. All your external protocols are gracefully brought down. Do you all remember what is graceful insertion and removal with routing protocols? Anybody remembers that? They're all IETF standards now. BGP was probably the last one to support. Cisco's proprietary EIGRP started supporting graceful insertion and removal long back. By the way, this is dependent on the routing protocol. BGP, ISIs, OSPF, they have all started doing graceful insertion and removal. What it does is these routing protocols, when they are put in that mode, they would actually, when the switch goes into that mode, they would stop sending their keep alives to the neighbors. So the neighbor switches will automatically go ahead and recalculate and change their forwarding path through some other redundant links. Okay. Each of these routing protocols had to be extended in order to support GIR. And that would be probably by 2009 or 10, all of the routing protocols we know used today have started supporting GIR. That's something that Nexus started doing. When Cisco first released Nexus, they actually used this feature, GIR, in Nexus platforms. Basically just removing the switch out of its forwarding path or isolating the switch. So when you go ahead and do the maintenance mode here, all the external protocols, whichever ones you have, except the internal ISIS protocol. The external ones are put into GIR mode, basically put into graceful mode. And then in ISIS, what it does is that particular switch is going to announce its routes with a very high metric. So it doesn't shut down ISIS, it basically goes with very, very high metric. And that means the spine is kind of saying, hey, you're way out of bound. Your metrics are too high, so I'm not going to send routes to you. We'll just send the routes to all other possible paths. Okay, so this particular switch, when it's in maintenance mode, in this example, it's a spine, but I'd like to say if it was a leaf, if this leaf was connected to another BGP peer, it would have announced through BGP saying that it's going down. And this way, ISIS would announce a very, very high metric. Here, of course, it goes down. So it does a graceful shutdown because BGP does support that. But within the fabric, what they've done is it announces a very high metric. So your switch is kind of going to be ignored. Okay, the ISI's routing table is going to calculate and see, hey, getting to this device is too high, so it's going to kind of not going to be a viable path. In addition, it shuts down all the ports. The access ports are also shut down. The fabric ports are up and running, but the access ports are shut down. The switch will be decommissioned, rebooted, recommissioned back. When it reboots, when it's recommissioned back, all its BGP starts functioning, ISIS comes back to its default values, like after 10 minutes. That's a very nice approach to go ahead and take it down. That's what it's actually showing you. And we have gotten to the end of that chapter.